Okay, let's start looking at how vertical asymptotes can use some limits as well when we're trying to figure out some behaviors. So here it says vertical asymptotes can occur where there are restrictions in the denominator. So you've seen some of this stuff in advanced functions. So the examples that are here, it seems like I have a restriction here at x being a -1, and there was an asymptote there. Here there's a restriction at x being a -1, but there's no asymptote there because if I factored that, there'd be some canceling. So restrictions aren't the only thing that we need to consider. We actually have to dig a little bit deeper to see if things can cancel. In general, we would say this about vertical asymptotes. A function f has a vertical asymptote at x being a if one of the two things applies. If, as we approach a from the right, it's either going to be tending towards positive or negative infinity, or as we approach a from the left, we're tending towards positive and negative infinity. What this is essentially saying is that at a, your function is either climbing up an asymptote or going down an asymptote. And it could do it on either side. It doesn't have to necessarily do it on both. You've seen some functions like, for example, the logarithmic function, where the asymptote only really applies to one side of it. So that logarithmic one would be something like this. If you look at the basic log, it only has a limit existing on one side, or it's not even existing. The limit as we approach one side going to positive or negative infinity, and on the other side, there's no function to even consider. So only one of these has to actually apply. If they both do, that's fine, but it really doesn't matter. As long as one of these applies, we know there's a vertical asymptote at A. So let's look at ways to deal with this. So you guys have seen some ways of using information to determine behaviors around asymptotes before, and most of it was just plugging in numbers and guessing and checking, which is not ever ideal. So let's come up with a better technique. Here it says, let's look at the vertical asymptotes around this function, and it's nice and factored for us already, and then determine the behavior. I know there's going to be a vertical asymptote there and there because we've seen functions like this. There's nothing funny going on. We'll investigate that later. So let's just assume an asymptote exists. We'll be able to prove it in a second. What I am going to do is focus in on, let's say, one side, and then I'll explain this. So here I'm going to focus in on the x being, or x equals 3 asymptote. As we approach 3 from the right, then there's going to be an asymptote if this starts tending towards either positive or negative infinity. So there's a technique that you can use. It's, you know, kind of picturing numbers and how they kind of relate to one another. It's not too formalized. So think of it like this. As x approaches 3, what's going to end up happening is my numerator is going to be 3, which is a positive number. I'm not too concerned how big the number is. I'm concerned how small the number is. And its sign particularly is of interest. So as x approaches 3, the numerator is going to be a positive number, being 3. I don't care that it's a 3, I care that it's a positive number. The x plus 2, as x approaches 3, this is going to become a 5, which is a positive number. And then this x minus 3, well, this thing's going to tend towards 0 as x approaches 3. But the fact that this is 3 from numbers that are greater than 3 means that if I were to plug in a number slightly greater than 3, that this thing here is really, really close to 0, but it's positive. So what that means is, in terms of how these factors kind of correspond with one another, I'm going to be taking some number and essentially dividing it by 0, because 0 times anything is going to be 0 down here, which means it's going to infinity. The fact that it's going to positive infinity is because all of these are positive. Using the same kind of idea, let's look at here. So let's look at the other side of 3. Same thing, as I approach 3, this is going to be positive. This is going to be positive because it's going to be a 5. But then this thing here is going to start tending towards 0, but now it's a number that's slightly less than 3, which means if I were to substitute it in here, that's going to be a tiny negative number. So the fact that, again, I am dividing by a negative, or sorry, dividing by a 0, I'm going to have an infinity. But now I've got two positive numbers and a negative factor, which whenever you only have an odd number of negative factors, the entire thing is overall negative. So this is tending towards negative infinity. I didn't have to plug really anything in other than just kind of conceptualize it. And then same kind of idea here. If we look at the asymptote at x being negative 2. As we approach negative 2 here from the right, then this numerator now, think of that as substituting in a negative 2. That's going to be a negative number. If I substitute in a negative 2 here, that's also a negative number. If I substitute in a negative 2 here, this is 0. But it's also a little bit more than negative 2, so this is going to be a slightly positive number, which means I'm dividing by 0, so it's going to infinity, but I've got an even number of negatives now, so positive infinity. Here, same kind of thing as I approach x being in negative 2. This is negative. This is going to be negative. This is going to be 0, but it's slightly less than negative 2. So that means that this thing here is going to be a tiny negative number. I've got now a divide by 0, so it's going to infinity, but I've got an odd number of negatives, so it's going to negative infinity. So again, I didn't really have to plug in weird decimals and do a guess and check to find this stuff out. Now I can, if I wanted to sketch the graph using this information, sketch it fairly easily. So let's do this. Let's try this example. It says determine all asymptotes and their behaviors for this function. So first thing that I can do is I'm going to get the horizontal asymptote going. So here, highest degree term is x to the 1, so we're going to multiply everything by 1 over x, numerator and denominator. This is then going to tell me that my limit as x approaches infinity, these are going to go to 0, is going to be a 4 over negative 1, so a negative 4. I've got a horizontal asymptote. Okay. If I apply the stuff with horizontal asymptotes behaviors that we did previously, then I can make that difference function, f of x minus L, simplify the expression down so that I can chart it out. Okay. And now if I chart it out, and I kind of want it fully factored here, so that's why I went to this extra step. Now if I chart it out, and I simplified it further, then this is what's going to happen. So let me get the chart in so we can explain it. I've got my only restriction here at negative 3. I've broken the domain up there. I've got the factors here. I got some things canceling out. So the factors that are left, I've got a positive 11, which really doesn't do anything, and the x plus 3, which changes over at negative 3 from negatives going through to positives. So this is kind of summarizing what's going on here. So what we've done previously, this is already telling me stuff about my end behaviors. So towards positive infinity, I'm above the asymptote, so it's approaching negative 4 from above. Towards negative infinity, I'm below the asymptote, so I'm approaching it from below. Okay, so that's what this is saying. But here's the vertical asymptote, and here's an extra way of doing it. This chart actually tells me what's going on here too, because on this side of it, in order to stay below the asymptote, I would have to go down the vertical in order to stay below the horizontal. So I know that I'm going down towards negative infinity. And on this side of the asymptote, which is here at x being a negative 3, if I have to stay above the horizontal asymptote, the only way that I can do that is by going up the asymptote on this side. So on this side, this is telling me it's going up. On this side, it's telling me it's going down. So I could even use that chart to tell me more information. So I've got kind of multiple ways of figuring out behaviors around vertical asymptotes.